Okay, this is the 6th grade tension and energy test. First question, we have a crate is hanging from a string and it has some sort of force of gravity. What is the force of gravity on that string? This is a question that is asking you to understand the difference between weight and force. How do I know? Because my units here are newtons. So I've already calculated the force of gravity on this string. It's 40. And if it's stable, if the forces are in equilibrium, there's no acceleration, then this must also be 40. It's tempting to miss this and say that this is a 40 kilogram object, in which case this would be a force of gravity of 400 and this would be 400, which would be incorrect. The way that and this is not what the problem asks, but the way that I would convert between weight and mass is to remember that my force of gravity is going to be the mass times the acceleration due to gravity, which I usually round up to 10. And so in this case, if I wanted to convert that, it would be 40 newtons equals some sort of mass divided by the acceleration due to gravity. So the mass would be 10 kilograms. That's not necessary for this problem, but do be mindful that sometimes these are given in weights and sometimes it asks for weight. And when you do that, you have to convert or be mindful of this unit. Okay. So we have here for problem number 2 a 2 kilogram toy. It's being pulled at constant speed with 10 newtons of force this way, and there's some sort of force of friction. How do I know what this force of friction is? My clue word is constant speed. This means my acceleration is 0. If my acceleration is 0, that means my forces must be in equilibrium. Meaning that, excuse me, meaning that if I have 10 newtons of force on this side, I must have 10 newtons of force on that side, and that is what this problem is asking. A fisherman has caught a 6 kilogram fish. The friction in the water is 18 newtons. If the tension on the fishing line is 60 in order to accelerate the fish towards the fisherman with 0.5 meters per second squared, how much force is the fishing line pulling, how much force is the fish pushing against the water? This is a combination of forces problem. So this is going to be force 1 plus force 2 plus force 3 is equal to mass times acceleration. This is an extension of the force is equal to mass times the acceleration, right? Because technically this is force net, right? Which would be just the sum of all the different forces here. So let's go ahead and do a free body diagram. Here's my picture of a fish. It's a lovely picture. Best picture of a fish ever. And this is not really necessary for a free body diagram, but it's helpful to sometimes see. Here's my fisherman, and he has he's pulling on the fish with some degree of tension. I look to the problem, I see it's 60 newtons this way. And I have some form of friction here, and it is going in the opposite direction. How do I know? Because I know that the overall direction of my fish is in this direction, and I know friction has to be opposite the direction of motion. So this is going to be 18 newtons. And I know that the fish is struggling against the fisherman. The fish is pushing a force this direction, and I don't know what that is. So force of some sort of applied force here. So how do we figure that out? We put all of these numbers into our equation. So this is going to be 60, that's my force of tension, plus a negative 18, right, because it's going in the opposite direction. If this way is positive, this way has to be negative, plus some sort of negative applied force is going to equal the mass, which is 6, times my acceleration, which is 0.5. Okay, we now have enough information to solve this problem. So 60 minus 18 is 42, minus some applied force from the fish is going to equal 6 times 0.5 is 3. So I'm going to subtract 3 on this side, and I'm going to add friction to the other side to make it positive, and that is going to give me 39 equals my force of friction. And that's it, 39. Object 1 is 40 kilograms, is hanging from rope 1. Object 2 is 20 kilograms and is hanging from object 1 with rope 2. What is the tension on this first rope? Well, I have an acceleration due to gravity here of 200, right? That's 20 times 10. And that's pulling on this from with 200. And this has its own force of gravity, which is downwards of 400. And so this rope must be 200 plus 400, 600 up in order to support all of that weight. So that is that. A crane lowers an 80 kilogram container onto a ship with an acceleration of -2 meters per second. What is the tension of the force on the cable? Now, free body diagram, we have 80 kilograms. My force of gravity is going to be 800. This is in newtons. And so what is my tension going to be? So again, we need our combination of forces. So F1 plus F2 is equal to ma. So F1 is going to be 800 plus some negative force of tension. Actually, you know what? I'm going to do it the other way around. I'm going to do a tension is minus, I'm going to make up positive, is going to equal my mass. And the reason I'm doing that is because I see my acceleration is negative. So my mass is going to be 80 times a -2. Okay. So T minus 800 equals 160. That's negative. And then I'm going to add 800 to both sides. And that T is going to give me 640 newtons. Right? And this makes sense, right? If it was more than 800, then it would accelerate in this positive direction. If it's less than 800, as it is, 640, then it's going to accelerate in this negative direction. Right? And so we combine these to get the total acceleration, which is what we've done here. This is a relatively simple problem in the sense that there's only one step. This is an 8 kilogram book. My force of gravity is going to be the mass times the acceleration due to gravity, which is 10. So it's going to be 80 newtons. Keep in mind that this is not the correct answer, that we are in newtons, not kilograms. Sometimes we get confused and we say that kilograms is a mass. It is not, kilograms is a weight. It is not a weight, it is a mass. Our weight is always going to be a force and in newtons. A 30 kilogram box is being pulled to the left with 90 newtons of force, and it's being pulled to the right with 90 newtons of force. The box is moving at a constant 6 meters per second. What is the acceleration of the box? Okay. Our clue word here is constant. If it's constant, then the acceleration has to be 0. I don't have to do any calculation at all. I just have to read and understand the question. Right. A 75 kilogram box is hanging from a rope. Cool. 750 going down. It's moving upwards at a constant speed. Okay, constant. That's again my clue word. This means my acceleration is 0. Of 5 meters per second. What is the tension on the rope? Well, if my acceleration is 0, that means my forces have to be balanced, which means that my tension has to equal the acceleration due to gravity. If I wanted to accelerate it from 0 to 5 meters per second, maybe in some amount of time, then I could calculate the extra force needed to do that, but that's not what this problem is asking. Once I've done my acceleration around a constant speed, then the tension is just opposite the force of gravity, even if it's moving. A train engine is connected to the 2 train cars as shown. The engine has a mass of 700 kilograms. Each car has a mass of 500 kilograms. The force of friction on each car and the engine is 20. what is the tension on the first cable, that's this one here, between the car and the train is traveling at constant speed? Okay, well, if it's constant speed, that means my acceleration is 0. And so that means that my force this way has to be balanced with my force this way. So my force here is going to be 200. And then my force in this direction has to be 400. And that's the tension on the cable. A train engine is connected to 2 train cars as shown. The engine has a mass of 700 kilograms. Each car has a mass of 500 kilograms. The force of friction on each car is 200. What is the tension on the first cable if the train is accelerating at a rate of 5 meters per second squared? Okay, so the first part is easy because it's the same as the previous part. We have units of forces of friction here as a total of 400. What is my tension going to have to be on this in order to accelerate these things 5 meters per second squared? All right, well, my force equation is mass times acceleration. My mass, there's both of these, is 1,000 times my acceleration, which is 5. So that is going to equal 5,000 plus my 400 from my friction. It's going to give me 5,400. There you go. If a 400 kilogram car went from 4 meters per second to 29 meters per second in 5 seconds, how much force would be applied to the car? This is my force is equal to mass times acceleration. My mass is 400. My acceleration is going to be my change in velocity over time, which is going to be 29 minus 4 over 5 is 25 over 5, which is going to equal 5. So that's 5, and so 400 times 5 is going to equal 2,000. A block of wood has an unknown weight. Be very careful because it's asking about weight. It accelerates at 2 meters per second when a 10 Newton force is placed on the block. What is the weight of the block of wood? What is my mass? I don't know what my mass is. Let's find out. It's being pulled this direction with 10 newtons of force. So let's put this into our equation. Force is equal to mass times the acceleration. So this is going to be 10 equals mass times 2. Divide both sides by 2. My mass is 5. Mass is not weight. I have to multiply by 10 in order to get my weight, which is 50 newtons. Its 600 kilogram plane is very little light plane. Is sitting on a runway. Its engines place 2,100 newtons of force on the plane. If it takes a velocity of 90 meters to take off, how long did it take to take off? Okay, so how long, that's a time. And we have a initial velocity of 0 and a final velocity of 90 meters. And an acceleration of, we're not sure yet. So let's figure out our acceleration. We're going to use force is equal to mass times acceleration. Our force is 2,100. Our mass is 700 times acceleration due to gravity, or just acceleration, divided by 700 on both sides. Acceleration is 3. So now I have 3. So let's over here, my acceleration is my change in velocity over time, which is going to be 90 equals 3. Which is going to be, so cross multiply, we rearrange this algebraically, that's t is equal to 90 over 3, which is going to equal 30, and this is in seconds. There we go. A 60 kilogram astronaut in space accelerates a 10 kilogram tool from 2 meters per second to 8 meters per second in 2 seconds. How much does the astronaut accelerate in the opposite direction? Remember, this is a Newton's third law problem. So every action this way, by action we mean force, has an equal and opposite force this direction. So the force on this one is 10 times my acceleration. My acceleration is going to be 8 minus 2 over 2, which is 6 over 2, which is equal to 3. So 10 times 3 is going to equal 30, and that is my force. That is my force on this one, so I have to have an equal and opposite force on the astronaut. So if the astronaut has 30 newtons of force this direction, he has a mass of 60, I need to know my acceleration. Divide both sides by 60, and 30 divided by 60 is 0.5. We'll accelerate that direction. All right. An 800-kilogram car is traveling along the road. The engine places 3,200 newtons of force in the car. The car accelerates for 5 seconds and a final velocity of 30 meters per second. What is the initial velocity of the car? I'm going to need my force is equal to mass times acceleration equation, and my acceleration is equal to my change in velocity over time equation. Let's start with my force so that I can figure out what my acceleration is. I have 3,200 right here equals 800 times my acceleration, divide both sides by 800. Acceleration is 4. All right, and if my acceleration is 4, it's going to equal my change in velocity over time, which is 5. And so that's going to be 20 equals my initial velocity of 0. Oh, we don't know my initial velocity. My final velocity minus initial velocity is going to be 30 minus my initial velocity equals 20. So subtract 20 from both sides, add my initial velocity to both sides, and that's going to give me my initial velocity is equal to 10. It's 600 meters to Billy's school from his house. If Billy starts at 7:30 and gets to school at 7:45, realizes that it's Saturday, so there's no school, turns around and goes home. He gets home at 8:30. What is Billy's average speed? All right, so he was gone for 1 hour. So this is my total time. This is my total time is going to be 1 hour over my total distance, because I'm looking at speed, right? This is not velocity. And my total distance is going to be 600 plus 600, because I'm going there and back. So I also need this to be in seconds, although I realize I have made a mistake. Can you tell what mistake I've made? I've gotten these switched around. One of the ways that you can test yourself or kind of check yourself to see if you're making a mistake is look at my units here in meters per second. If I complete this calculation as it is, I'm going to have seconds per meter, and that's going to give me the wrong result. So let's go ahead and flip this around. Our speed is going to be distance over time. So total distance over total time. All right, much better. So this is going to give me 1,200 meters over 1 hour. Now this is in seconds, not hours. So we need to be in hours. So how many hours are there, or how many seconds are there in an hour? There's 60 minutes, and for every minute there's 60 seconds. So 60 times 60 is 3,600. And this is going to give me a average velocity of 0.33. There we go. Jack is playing baseball. He swings a bat at 2 kilograms at a 2 kilogram ball traveling negative 5 meters per second. The ball leaves the bat at 0.1 seconds, going 5 meters per second. If it takes 0.8 seconds to swing the bat, what is the final velocity of the bat as it struck the ball? We're ignoring friction in this problem. Okay, so for this one, this is again a Newton's third law problem. I have a bat and I have a ball. The force acting on the ball is going to be the same as the force of the ball acting on the bat. Right? So we have to figure out what that force is. I know that the acceleration is going to be my final velocity minus initial velocity over time, which is going to be positive 5, because that's my final velocity, minus a negative 5 over 0.1. That's going to be 10 divided by 0.1 is 100 meters per second squared. Lots of velocity. My force is going to be mass times acceleration, which is this is 2 times 100, which is going to be 200 newtons. Okay, so if I have 200 newtons of force this way, then I have 200 newtons of force that way. All right, so what velocity does my bat have to have in order to accelerate this much, in order to have 200 newtons of force? So let's figure out my acceleration. So if I have 200 newtons of force is equal to my 10 kilogram bat, my acceleration, divide both sides by 10, my acceleration here is going to equal 20. If I'm starting at rest and this is my time, what is my final velocity? So this is going to be my final velocity over 0.8 is going to equal 20. So multiply both sides by 0.8. It's 20 times 0.8. 0.8 equals 16, and this is in meters per second. There we go. A 2 kilogram ball is sitting on the ground. If a 50 kilogram athlete comes and kicks the ball with 100 newtons of force, what do we know to be true? This is asking how well you understand Newton's third laws. So if I have a foot here, and I have a ball here, I'm going to place some force on this ball, and I know that the ball is going to place some force on this. If you have ever kicked a ball good and hard without any shoes on, then you know that there's definitely some sore toes involved. So you know that the force of the ball is definitely putting a force on the foot. All right, so we know that these are equal and opposite, but does the ball move? It does move, so this can't be true. The ball must move because the forces are balanced. The forces are not balanced because we know that the ball is accelerating. The ball must move if the forces are unbalanced. That is true. Because there's an equal and opposite force, the ball doesn't move, but the athlete does. Now, that's just silly. Okay, the ball must move because the forces are unbalanced. If these are equal and opposite forces, how can they be unbalanced? Well, they are balanced between these two, but equal and but unbalanced forces just means for this object here. The equal and opposite forces happen on two different objects. My net force is just on the one. So there is no counterbalance force acting on this to keep it in motion, right? So it is going to accelerate. Their forces are unbalanced. If I have Newton, okay, we're asking about weight. What is the mass of the book? So we have a little table. We have some sort of book here, which the mass we don't know. The weight is 5 newtons. What is the mass? So our acceleration due to gravity is going to be mass times the acceleration due to gravity. The mass we don't know, but we do know that the weight, the acceleration due to gravity is going to be 5 newtons. Mass times the acceleration due to gravity, which I round up to 10, divide both sides by 10, mass is equal to 0.5. If a 40 kilogram box is hanging from a string, what is the tension on the string? Similar problem. 40 kilograms. My acceleration due to gravity, my force of gravity here is going to equal 400. That's 40 times 10. And my tension, if it's not moving at all, is just going to be 400 as well. So that's it. And that is the test.